Hello, everyone. We've reviewed the principle of just-in-time, or JIT, as the main driver of quantity control in lean production. JIT means producing only what is needed, when it is needed, and in the quantity needed, and, importantly, enforcing this throughout the production. We've also understood that to realize JIT, we need a stable pull system. We've looked at the basics of planning, and we've seen how the widely used MRP, or Material Resource Planning, works as a push system. We now want to look at scheduling, and scheduling is the core of lean production. This is where the master production schedule, our plan, is translated into a work schedule for the production floor, scheduling what is to be worked on and in what sequence in the near term, for example, the next week, the next day, or the next shift. And so in this session, we want to understand the difference between scheduling in push systems and in pull systems. But first, let's look at our product process matrix that we saw at the beginning of the course. And again, we had across the top here the job view, where we moved from highly customized, high product variety to highly standardized, limited product variety. And on the vertical axis, we had the resource view, where we moved from craft production in a job shop to high volume production, continuous flow. Now, when we think of lean production, and indeed a lot of the literature and the courses on lean, we are focused here in this lower right corner. Here we have no shared resources. There are no batches or limited batches. We're working in pull, following our TACT, the pull of the customer demand, and this is our ideal case. Further up, we're looking at production with shared resources, dealing with batches, and, of course, our setup times. Now, most manufacturing is a combination of both. And even Toyota, which developed the Toyota production system over decades, has shared resources in its production. Now, typically, you have more batch processes upstream, while downstream, closer to the end of the production, you would aim for the continuous flow. Now, in our lectures, we are also going to focus on the classical lean model. We're going to be looking at this area where we're scheduling for production with minimal shared resources and minimal setups and changeovers. We have reviewed our planning function, and we've understood that the master production schedule, our plan for the production, needs to be converted into a work schedule to guide what the actual production on the factory floor will be doing. Now, we also understood that the objective of the MRP is to meet our end demand given by the plan and to incorporate things like safety stock levels, lot sizing requirements, make sure the materials are ordered on time, and this will then generate a planned schedule for material management, inventory, and production control. Now, as we emphasize, these planned order releases generated by the MRP are based on forecasts, planned forecasts, and these are then pushed into the production. So let's look at how this works. In our push system, the orders then are planned centrally, and the schedule for the production is pushed to each operation. The MRP is regenerated at the end of each planning period, and the production plan is then updated. So in the long run, you have supply matching the demand, but inventory and backlogs or late orders are then created in the meantime as your push system continues. In a pull system, processes are triggered, are authorized by a replenishment signal from a downstream operation. So here we have our downstream operation, step 4, which is closest to the end demand for this system. Step 4 will look at the end demand and request material from step 3. Then, and this is the important part, the schedule for step 3 will be based on requests from step 4. Step 3 will look at the demand and will then send a material request upstream to step 2, and The schedule for step 2 will then be set by the request from step 3, and so forth and so forth. So only upon the withdrawal of material from inventory are the preceding processes authorized to start processing. This then pulls the material through the process. The furthest resource downstream, closest to the market, will follow the customer tact and relay this demand step by step upstream so that the external demand is then transferred step by step upstream. So how do we realize this type of pull scheduling? In the next sections, we'll review scheduling concepts used in lean production to make this happen. We've already mentioned the importance of tact in pull systems. In the next lectures, we'll reiterate the importance of understanding and smoothing demand and introduce scheduling concepts such as production leveling and ways of implementing pull scheduling.